You have the power. 4 exponential equations are written below. What do these equations have in common? Is that the only thing they have in common? So yes, the first thing you said was the right answer. I just wanted to make you think a little bit more. I know I'm such a bully. Okay, so what do these equations have in common? They're all raised to the x power. They all have an exponent of x, anything like that. Any kind of terminology, as long as it's correct, would be nice. Okay? So, here's what's going to be really hard about this paper. You guys know I try to be honest with you about stuff like this, okay? And I think we had this talk the other day about the fact that some of the things in relation to logarithms, I have to teach you the long way because I don't know. Did we have this discussion? Let me I'll just be clear, okay? As high school math teachers, we are required to teach you with technology, with calculators, right? That's one of our requirements as a teacher. It's in my TEKS. It's listed over there. You can go look it up. It says with technology using calculators, okay? But in college, sometimes they don't let you use them at all. Not even like a little 4-function calculator or anything, right? So that's a weird and different thing because it's like there's no communication going on there. There is, I promise, okay? But it's going to take probably a little bit more conversation, all right? I am currently having conversations with the other teachers in my study group, in my master's group that we're getting our masters all together, because at first they were like, why do you do that? I'm like, I have to. And they're like, what do you mean you have to? And I was like, it's in our TEKS. And they were like, oh my goodness. Yeah. Well, I mean, we want kids to be able to not have to use a calculator. And I was like, me too, but I'm required to use it. You know, I always show you guys stuff how to do by hand first and then show you the calculator, don't I? Okay. But we're kind of like between a rock and a hard place because we have directions and they have directions. And even the weirder part is I was tutoring some kids in college algebra a couple years ago. Both of them were going to Texas Tech. One of them was allowed to use a calculator and one of them wasn't. At the same college. Not the same teacher, not the same professor. It even depends on from professor to professor. That's hard to say, okay? But some of the stuff that I have to teach you in this lesson today, it is so amazingly simple with a calculator. But if you don't have a calculator that will do what these calculators can do, or if you're not allowed to use the calculator, well, if you're not allowed to use a calculator on this lesson, you're probably in trouble. Okay? There's probably just a whole lot of steps you're going to be able to have to write, and you won't be able to get a solution if you can't use a calculator. Okay? But if you have a calculator, like a 4-function calculator, or even like the calculator on your phone, you can do the way I'm going to show you, the long way. But if you have these calculators, so simple. So I have to show you the long way first, just in case, because I don't know where you're going. You know what I'm saying? I don't know where you're going to end up as far as what college or whatever taking the college algebra. So I want to make sure you understand the math, and then I can show you the shortcut with the calculator. Fair enough? Okay. So we'll get there. Okay. So to solve these equations, rewrite each in logarithmic form. So if we're rewriting a, how do we rewrite that into logarithmic form? Log base 2 of 20 equals x, right? Okay, so how do we rewrite b? Okay, so wait, this crazy kid last period, you know what he said? He said log of 48 equals x. And he didn't even say the 10.
That's right.
Is it wrong if I say the 10? No, but am I allowed to say it this way and write it that way? Why? Understood. It's the common log, right? It's the common base. Okay? So what about c? How do I write that? Log base 0.8 of 4 equals x. And the last one? Yes. Log base 2.718 of 60 equals x. Got it? Okay. Which of these 4 equations could be solved directly with a common log function on a calculator? Only b, right? Only b is a common log. So what is the log of 48? .68124. Okay. Nah, that's good. So but we better put this then if we're not putting the full number, right? Approximately equal to. Okay. The common logarithm of function on a calculator can evaluate logarithms in base yeah, 10. Yeah. No, it's okay. It was one of those questions that are way easier than you think and you try to overthink them. That's okay. It cannot evaluate logs for bases such as 2 or 0.8. Those just came from that was the first 2 examples right there. Okay. You could put anything else except for 10. Okay. Yeah, pretty much. Okay. All right. So again, because of where I'm going, I'm not going to do all these examples for you because of, like I said, because I know where we're going. Fair enough? All right. So let's start right here. One of the ways that we can solve these, if we're doing the long way on the calculator or with the calculator, is we start here, 2 to the x power equals 20. We want to take the log of both sides. But we are being very specific about what kind of log we are taking. What kind of log do we want to take? Log base 10. Absolutely. Because we can use the calculator for that, right? We can punch stuff in. So we're going to write log of 2 to the x equals log of 20. Now, do I have to write the base 10? No, and I probably won't because it's a common log, right? I don't have to write it, so I'm not going to take the time or waste the ink or lead. Graphite. Okay. So, what's the rule? The exponents on the argument are the same as the power. Yes? So, times the logarithm, right? So this power actually goes where? Down in front as a multiplier, right? So it's actually x log of 2 equals the log of 20. So what do I do to solve for x? How? How do I get it by itself? Of log of 2. If I divide both sides by log of 2, careful, I get x equals log of 20 divided by log of 2. Please remember that a logarithm is an operation. It's doing something to the 2. This is not something we can just cross out the logs, like simplify the logs and say 20 over 2 is 10 and that's the answer. That's not what's happening here. We're taking the operation of a logarithm of 20. Logarithm of 2. Okay? So we can't cancel out the logs. We can't cancel out those 2. We actually have to do the operation log of 20 divided by log of 2. When we do that, we get x equals like that, 4.32193. Exactly 4.32193? Or did you round? You rounded a little bit? Okay. That's not wrong necessarily. However, it will affect when we check. Okay? How many decimal places you go to will affect when you check. And here, let me prove it to you real quick. Okay? So how are we going to check if this answer is right? Plug it in to the original problem, just like we always do when we're checking, right? Go back to the original problem. 2 raised to the 4.32193 should equal 20 if we did it right. Does 2 raised to the 4.32193 equal 20? Probably not, but it's like 19.99. Probably your calculator it's already rounding it for you, so it's still holding on to that number right down here when it's raising it to the power. Okay. Watch. 2. I think your calculator's probably set at float, is my guess. Let's check and see. It's not that big of a deal. 2 raised to the 4.32193. See, it's rounding because I know it's not exactly that. I know it's not. But again, it's not that big of a deal. I just want to go look real fast if I can remember where float is. I don't remember where it is. Home, document, right here. Home, settings. That's not what I said, calculator. Yeah, see, it's on float on 6 for you. So if we make it go to... Oh, that's not what I wanted. Let's go float 12 just for giggles. So let's do a new document. No, I don't want to save the old. 2 raised to the... What is it? 4.32193? Well, that's so weird, because I know that's not right. Yeah, it still says 20. Huh. Can you trust me on this one? Okay. If you do this... No, I don't think it'll matter. It ends up being something like that. I can't remember exactly what the number was. I was hoping you'd tell me, but your calculator's being rude to me today. Okay? But it's something like this, and does that equal 20? No, but what we have to keep in mind is that this does round, and when we round up here, we're not going to get exactly 20 down here, but it is close enough at this point to say that yes, that is 20, knowing that we rounded. Did yours work? Okay, his did not equal 20. See what his did when he put that in? Isn't that weird? I'm sure it has something to do with the 20s.
Mine did the same thing. It's just that mine had the 20 and then the dot. So if you go up and hit enter again, it shows you.
So yours...
It's the same thing.
What did you do? So if you go hit... Oh, that's so weird. So it does round it for you, though. Okay.
It rounds for you, and then if you click it and hit enter, it shows you the full.
That's interesting. I didn't know that. Thanks. I didn't. Thank you for sharing that with me. I appreciate.
If you need a full number,
Oh yeah, I know you can go back up there. Yeah, I didn't think about that. Okay. Awesome. Thank you very much. Okay, so that it does check out though, right? So that is an appropriate answer. For the record, if you go further, more decimal places, it will give you a better approximation when you put it in as the exponent. Okay? All right, so next page. Here's where it kind of starts getting messy. Not so much as like hard stuff. It's just that I'm not going to do all this stuff for you because it's one of those situations. Do I show you the really long way for a really long time? Even though we're allowed to use calculators, I need to show you enough of it so you can recreate it if you don't have a calculator, or if you don't have a calculator that will do exactly this. But I'm not going to spend the whole entire period working on this when we have the technology that we can use. Fair enough? Okay, so let's do number 5. 6 to the x power equals 104. The first thing it asks us for is to rewrite it in logarithmic form. Okay, if I rewrote this in logarithmic form, what would I get? Log base 6 of 104 equals x, right? Okay. But what if I had to solve it by taking the log of both sides? Again, log base what? 10, but I'm not writing the 10, right? I'm just writing log, knowing that it's log base 10. So I have 6 to the x power here and 104 here. I'm taking the log of both sides. And that goes back to the fact where if you do something to one side of the equation and you do it to the other side of the equation also, it's still an equivalent statement, right? Okay? We haven't changed the value of the x by taking the log of both sides. Okay? So what happens to that x? Goes in the front on there. So I get x equals log of 6. Sorry, x times log of 6 equals log of 104. Then I would say log of 104 divided by log of 6, because I would be dividing both sides by log of 6 to solve for x. And in my calculator I could put log of 104 divided by log of 6. Yes? And what'd you get? Exactly? Okay. That's probably a good start though, right? Any questions about that? Okay. Depending on your calculator, you may need to know the change of base property. If we're using these calculators, you don't. But if you're using an 83 or an 84, an earlier calculator from these, you might have to. I've only not have to worry about really the change of base property only for the last couple years. Okay? Because these calculators, this technology will do the change of base property for me. But before that, I had to use the change of base property because the calculators were dumb. I mean, they're still only as smart as their users. They've just been programmed to be able to do more. Does that make sense? Okay? But you need to know the change of base property. And that's going to be log of n divided by log of b. Now, some people get confused about which one goes in the numerator and which one goes in the denominator. Can you think of any way that numerator and b would be the base, so the bottom, right? Okay. They don't always have n's and b's. You just have to remember that this is the argument, so it's going to go in the numerator, and the base is going to go in the bottom of the fraction or the denominator. Okay. So just for grins, just so we can make sure we've covered it, how would I rewrite this one in the change of base property? Yeah. And you could put that in your calculator and you would see that that equals 1.6 repeating. It's just a number. N is just a number. It's whatever the argument is. I honestly don't know why they chose to put an N there when we've been using an A for the argument the whole time. I think they're probably trying to confuse you. And I think you can rise above it. Okay? Do we need to do any more of those, or you got it? Okay. Absolutely, you can keep the fraction in. No, you can keep the fraction in. Okay? And if you did that one, you'd get -2. Okay? Any questions about that? Yeah, because 7 to what power would be 1 over 49? 7 squared would be 49. To make it 1 over 49, it would be negative. Okay? By the change of base property, log base n can be rewritten using common logs. We already know that. That's what I just told you. Rewrite each expression below? No. Okay, go to the next. This property allows us to easily graph logarithmic equations in the calculator. If we had to do it, you would know how to do it. Okay? So just for argument purposes, we would need to rewrite this as what? Log of x plus 4 over log of 2. And we could graph it and look at it, and that's all fine and good. We're not going to do it.
If we're rewriting that, so to be able to put into a calculator, just put log base 2 x plus 4.
Okay, you ready? Look at number 20. I'll answer that question in a second, I promise. Okay? All right, 20 is a little different because it is inequality. Okay? So real quick, we're going to look at this. Once again, you can put this straight into your calculator, but we're pretending you can't. Okay? We're just pretending. So log of x plus 5 over log of 3. And what would we put in y2? 2. Okay? So maybe I can do a better job this period than last period of drawing this. Last period it was awful. No, for real it was. Yeah, that's still awful, but I'll show you. I'll show you. Well, I mean, that's what we just did. We did change it. It's more like this. If you want to get it right, it's little, it goes up more, so ignore that part. Okay? So it's saying, when is the curvy part, the log part, less than 2, the horizontal line? Well, can you see that it's this part right here? Okay, so what do I need to know? I need to know the intersection, don't I? Okay. By magic, I've already found the intersection of 4, 2. You know how to do that, right? I'm not skipping over something you don't know how to do. Okay, 4, 2. No. No. Okay, no. We're going to do... This is how we've done that for a while. Anytime we have an inequality, we put one side in y1 and one side in y2, and we figure out where it's less than or greater than or whatever just by looking at the graph. Okay? All right, so the intersection's at 4, 2. So what x values can you tell me are less than that horizontal line of 2? X is less than 4. So everything that's less than 4? What about like -8? Oh, there's an asymptote, isn't there, right? We know about logarithms. There's an asymptote over here somewhere. Where is it? Well, knowing about transformations like you do, where's the asymptote? -5, right? Does that make sense? So there's the solution. From -5 to +4 is where the logarithmic graph is less than 2, less than the horizontal line. From the transformations. Yep. We actually got it from like right there because we know it moves left 5. Okay? Because of the parent function. All right? Is that okay now? Okay. So all we have left is the back. Okay? Now, I'm not going to show you a lot on the back, but I am going to show you some things that I want you to remember. And when I show you these things I want you to remember, you are going to laugh at me, and I am okay with that. I am confident enough in myself that you can laugh at me. What if I was solving this equation? But see, shouldn't I add the 2 and the 3 first? Yeah, you're looking at me like I'm stupid. You're like, oh my gosh, what an idiot. Okay? Except you're going to try to do that on these over here because you're not paying attention. Okay? We're trying to isolate that variable. What if that variable actually looks like this? Like that. Can I add the 2 and the 3? Even though it looks like I can I? No, I have to subtract the 2 first, don't I? Then I have 3 times 2 to the x equals 10. Now do I multiply these two? No, of course not. Right? I'm trying to isolate this variable, which means I'm trying to isolate that term, that whole term. So first I have to divide by 3, don't I? And so on. Fair enough? Okay. So when we get to problems like this, like number 25, what do I have to do first on number 25? Right, divide by that multiplier on both sides first. I cannot multiply these two together. I know it looks like you can, but you cannot. If I divide both sides by 1250, I get 0.8 to the x power equals what? 0.024. Now what should I do? I want to write it in logarithmic form, right? So that would be log base 0.8 of 0.024 equals x. No, and we can't, and this is why I'm going to show you, okay? We don't want to skip that step because we are going to solve it that way, okay? Because of the technology that we are required to use and that we can use, we are going to solve it that way. Menu, I want to clear everything out. Yeah, okay, let me show you what it looks like. Go the other way. Log base 0.8. See how I can put the base in? You couldn't used to do that. And I'm not saying in the dark ages when I was using calculators, because that's a joke, okay, in more ways than one, but whatever, of 0.24, uh-oh. And then all I have to do is press enter. Okay? Let me prove to you that this works, though, because it's a very easy proof. Okay? Log, what would the change of base formula be here? Log of 0.024 divided by the log of 0.8, right? Not there. Same exact thing. Same exact thing. It's just that our calculators can take a different base besides 10 and e. Fair enough? Okay, so from this point we are going to write it in logarithmic form, and then we can put that straight into the calculator to get our answer. Knowing that if you had to use a different calculator, you could do log of 0.024 divided by log of 0.8 and you would still get exactly the same answer. Okay? That's a good question. What do you need to round to? Let's go to 3 decimal places if it's necessary. Okay? 3 decimal places if necessary. Just real quick, let's talk about 22 real fast. Because you know what they tried to do earlier? Divide both sides by 14. No, you can't. Thank you. Oh, you cannot do that. I expected a snap or something, you know. Okay, so what do I do from this point? Yeah, I want to write it in exponential form, don't I? Log base 14, excuse me, logarithmic form. Thank you for the correction. Log base 14 of 91 equals x. And all that means is I have to say log base 14 of 91 equals, and then write down that number. So I ask for the thousandth, right? Tenths, hundredths, thousandths. So 1.709. That make sense? Yes, do the whole back. Now, what I mean by the whole back is I mean the whole back, including the bonus. It's not a bonus. It's an actual problem I need you to do. Okay? I do have the answer key pulled up on my screen if you want to come and check your work as you go. Otherwise, whatever you don't finish in class is homework. Preguntas?